Right, let's explore how you can figure out the length of a year on these two alien planets, Tinganan and Itnikud. So if you were an early person on one of these planets, you might notice that the sunrise and the sunset change just a little bit each day, and that those changes go along with how long the day feels and with the weather, whether it's warm or cool. And so you might want to track how these sunrises and sunsets move over time. That's really hard to remember. And so, in order to help you track it, you would want to write down what happened. You'd want to make something like a graph. So, here we've got a really primitive graph. We've looked at where the sun rises each day. We've split up a full circle into 360 degrees. Due east is 90 degrees, due west is 270 degrees. And we just marked where the sun rises. And that lets us put a number on the position of the sunrise. And so for day one, you could see that the sun rose almost perfectly east. So we put a dot over here above day one, right about at 90 degrees. Now, there were a couple cloudy days, day 2, day 3, day 4, we couldn't see where the sun was rising, but day 5 we sure could. And so we marked that down as well. And that was more like 82 degrees. So here's 80, here's 85. We put this right at 82. And then we had a long cloudy spell. And on day 19, we took another observation and we saw that it was about 68 degrees or so. And so we can see that that sunrise is moving gradually toward the north. And if we extend this graph out, if we kept doing this for more days, we could see if we can find when that pattern starts to repeat, when the pattern starts to do exactly the same thing again. And that would give us the length of a year. How many days does it take before the pattern starts to repeat? So we have given you a great tool to help you analyze this on these two different planets. So all you have to do is enter in the day number. Down here, there are a couple of different times that you can do this. If you go to the latest time, you get the most information because you've invented things like the thermometer or the clock. So you get the most information and the most graphs. If you want a bigger challenge, you can go way back to the first one where all it tells you is the sunrise and sunset. But no matter which of these you're trying to use, you just type in a day number here and it will make an observation for you. It says on day 1 that the sunrise was at 88.4 degrees. So just a little bit to the north side of due east. And the sunset was at 271.6. So the sunset was over here. 271 would be like right here. So it's just about perfectly in the west. The temperature was 63 degrees, and the length of the day was just a little bit longer than 12 hours. Now, if you type in more days here, like we did on our graph, it will build that same graph for you. The more days that you put in, let's see, maybe we want to try 25, 35, the more dots it will put on your graph, the more observations you'll have, the more information you'll have. If you scroll down, you can see the temperature moving, you can see the length of the day moving, you can see the sunset angle, you can see the sunrise angle, and you're just going to keep putting days in here. You can try any days you want between 1 and 999. So you could put in 400 here if you want. And since 400 is so much bigger than all these, it's stretched way out. All you do is enter days here until you feel like you can figure out when it's repeating. You can start to see already that, man, that sunrise got closer and closer to the north, and then it started to come back. And now, after 50 days, it's actually a little bit further toward the south, right? It's almost to 100 degrees. It's almost down here. And if you keep going, you can see how that pattern evolves. So you get to explore, you get to experiment, you get to play around and see if you can figure out the length of a year by trying to find when this pattern repeats. Enjoy.